See here, in the previous class, we clearly discussed about our features of Java. In the features, we discussed about platform independency. Okay, interviewer may ask like this: is Java platform dependent programming language or platform independent programming language? Okay, is C, C++ or the platform dependent programming languages or platform independent programming languages? Interviewer may ask like this. So C, C++ are the platform dependent programming languages, whereas Java, Python, C#, these are the platform independent programming languages. In the platform dependent programming languages, platform means combination of operating system and microprocessor. Combination of operating system and microprocessor is called a platform. Every operating system has its own language and every microprocessor has its own language. The instructions which can be understood by one operating system may not be understood by the other operating systems. The instructions which can be understood by one microprocessor may not be understood by other microprocessors. So communication problem may occur here. Okay. C, C++ are the platform dependent programming languages because after compilation of a C or C++ program, it generates exe file. After compilation of a C program, for example, this is a C program we are compiling. After compilation, it is creating exe file, executable file that contains a machine code. That machine code will be generated according to the operating system and microprocessor installed in the computer. For example, in this computer, Windows 10 operating system is there and Intel microprocessor is there. So according to the Windows 10 and according to the Intel microprocessor, this machine code will be generated. So this machine code generated for Windows 10. So you can run this code directly in the Windows 10, but you cannot run in another operating system because communication problem will occur here. This exe file has Windows machine code. Windows machine code cannot be understood by Linux or Unix or any other operating system. So you cannot run on the computers which are having different operating systems. So you can say the C, C++ are the platform dependent depending on operating system. Whereas in case of Java, after compilation, it is not generating exe file here. This is a Java program. After compilation, it is not generating exe file. It is creating intermediate code file. I'm calling that as byte code. When we compile the Java program, byte code will be created. So if you want to run this Java application on any other computer, simply take this bytecode file and place it. Who is responsible to run this bytecode? JVM. JVM is the special software to run the Java applications. We use this software. So JVM stands for Java Virtual Machine. It is used to run the Java applications. So we must install JVM to run any Java application. So simply we place bytecode file. That JVM translates bytecode to the machine code according to the operating system installed in that computer. So in this example, here JVM translates this bytecode to the Windows 10 machine code. In this example, JVM translates this bytecode to the Linux machine code. So even if operating system is same or different, just simply place the bytecode file, then you can run. So operating system is not responsible to run the Java application. JVM is responsible to run the Java application. So hence Java is becoming platform independent. We can run on any operating system, on any microprocessor. Whereas C++ platform dependent. We can run on same operating system only. We cannot run on different operating system. So these things we discussed in the previous session. That is called platform independency. In platform independent programming languages, after compilation, intermediate code will be generated. In the Java, we are calling that as bytecode. Next one, machine independent programming language. Machine independent programming language. So what is this machine independent? Listen. See, C++ are the machine dependent programming languages. C++ are the machine dependent programming languages. What is the meaning of it? So the application developed in C++ can run on computer only. The application means the software developed in C or C++ can run on computer only. We cannot run on many electronic devices like router is there, ATM machine is there, ATM machine, set-top box, okay, Blu-ray DVD player, remote control, smart cards, etc. You cannot run on many machines, okay, like routers, ATM machines, set-top boxes, remote controls, mobiles. So in such type of small electronic devices, we cannot run C or C++ application. So the application software developed in C, C++ can run on computer only. We cannot run on many electronic devices. So that's why we are calling C, C++ or the mission dependent programming languages. Whereas this Java is mission independent programming language. Java is mission independent programming language. The software developed in or the application developed in Java can run on many machines. Okay. Apart from computer, we can run this Java application on smartphones, tab, on remote control, on printer, on ATM machine, on Blu-ray DVD player, on set-top boxes, on routers, parking machines, sensors, smart cards, etc. So like this, Java supports to billions of devices. Okay, the software developed in Java, we can run on billions of devices. And billions of devices we can run. Okay, whereas if you develop the software in C, C++, you can run on computer only. You cannot run on many devices. Whereas the software developed in Java, you can run on not only computer, but also we can run on many devices like smartphones, tabs, personal digital assistants, okay, remote controls, okay, ATM machines, uh, on Blu-ray DVD player, on the printer, on the set-top boxes, on the router. Like this, it supports to billions of devices. So these two are the very, very important features which brought so many changes in the software industry. So before this Java, platform dependence, platform independency feature was not there. Before this Java, machine independency feature was not there. We develop the software in C, C++ means we can run on computer only. We cannot run on many devices. If we develop the software in C, C++, okay, if you develop the software in Windows, you can run on Windows machines only. You cannot run on other operating systems, other platforms. That was the situation before 1995. But when Java introduced, okay, Java came with the primary code. There is or write once, run anywhere. Okay, the main goal of Java is write once and run anywhere. So develop the application for one time. You can run that application on any platform, on any machine. This is the goal of the Java. So with this intention only they develop. So these two features brought so many changes in the software industry at that time. Before Java, these features were not there. Actually, Sun Microsystems company got a project from one electronic devices company. That electronics devices company wanted to run their application on many electronic devices. So James Gosling and his team started to develop the project. But at that time, they were facing so many problems due to the platform dependency and machine dependency, because their customer wants to run on many machines and on different platforms. But James Gosling and his team tried to develop the project in C, C++, but they faced a lot of problems. So that's why they developed a new language first, that is Java. Then they developed the project for their customer. Okay. So this is about platform independency and machine independency. So very simple, platform independency means the software developed in Java can run on any platform, like any operating system on any microprocessor we can run. Machine independency means the software developed in Java can run on many machines, like computer, smartphone, mobile, tab, printer, set-top box, etc. Next one is pure object-oriented programming language. I'm calling Java is the pure object-oriented programming language. So interviewer may ask like this: is Java pure object-oriented programming language? Yes, Java is pure object-oriented programming. Okay. So then, what is the meaning of it? In the introduction class, I already told that if any language that supports the four object-oriented concepts like encapsulation, abstraction, inheritance, and polymorphism. If any language that supports to these four concepts, you can say that language as the object-oriented programming language. So Java supports to these four concepts: encapsulation, abstraction, inheritance, and polymorphism. You can say Java is the object-oriented programming language. But I'm calling this Java is the pure object-oriented. What is the meaning of this pure? See, first OOPS concepts or introduced in late 1950s. In late 1950s, OOPS concepts were developed. Okay, so these OOPS concepts were introduced in 1950s. Based on the concepts, they developed the languages. Okay. In 1960s, in the early 1960s, first object-oriented programming language developed. That is Simula language. Simula is the first object-oriented programming language. So first they developed concepts, object-oriented programming system concepts. OOPS stands for object-oriented programming system. So first OOPS concepts were developed in the 1950s. Massachusetts is one private university. That Massachusetts private university developed these OOPS concepts. So based on those OOPS concepts in the 1960s, this similar language was introduced. So first concepts were developed. Based on the concepts, languages were developed. Okay, but first famous object-oriented programming language is C++. The C++ introduced in the 1980s. In the 1980s, C++ was introduced. When Java was introduced, officially announced in 1995, but first version released in 1996. Okay, so according to the object-oriented programming standards, each and every member should be defined inside of the class. Then we can call that language as the pure object-oriented programming language. So according to object-oriented programming rules, each and every member should be defined inside of the each and every member should be defined inside of the class. This is the rule. Okay, so first they developed OOPS concepts. Based on the OOPS concepts, they developed languages like Simula, C++, Java, Python, etc. So according to the object-oriented programming rules, each and every member should be defined inside of the class to provide basic security for the members. So to provide basic security for the members, each and every member should be defined inside of the class. In C++, we write the program in the form of classes, and we can write the program in the form of functions also. Okay, so class C1, starting point of class, ending point of class. In the class, we define some properties and methods. Properties and methods. So like this, we can define any number of classes. Finally, we define the main method. Observe carefully here. We are defining this main method outside of the. Here we create the object and invoke the members. So this is the structure of C++ program. So here we are defining this main method outside of the class. But according to the object-oriented programming rules, each and every member should be defined inside of the class. Main is also a member, main is also a function, but we are defining this main method outside of the class. Okay, and not only main, you can define another functions also. Like for example, I'm defining F1 function here. F1 function I'm defining outside of the class. Okay, if I want to declare the variables outside of all classes and functions like this, I can declare global declaration. So this X is the member I defined outside of the class. Okay, this F1 is the function I defined outside of the class, and this main is also a function I'm defining outside of the class. So we can define the members outside of the class also in C++. So with this, some security problems may occur. That is a problem here. So that's why you can say this C++ is not pure object-oriented programming language. C++ is not pure object-oriented programming language. C++ is not pure object-oriented programming language. Why? Why it is not pure object-oriented? Because we can define members outside of the class also. We can define the members outside of the class also. So that's why it is not pure object-oriented. Whereas if you take Java, in Java, we define each and every member. Okay, we define every member inside of the including main method also. Main method also we define inside of the class. So in Java, we define each and every member inside of the class, including main method. Main method also we define inside of the class only. Without the class, you cannot write the Java program. So minimum one class is required to write the Java. So minimum one class is required to write the Java program. In C++, we define main function outside of the class. So not only main, we can define other functions also. We can declare other variables also outside of the class. So C++ is not pure object-oriented programming language. Whereas in Java, we define every member inside of the class, including main method. Main method also we define inside of the class only. To write the Java program, minimum one class is required. Okay. So without class, you cannot write Java program. So that's why you can say this Java is pure object-oriented programming language because we define each and every member inside of the class. So Java is pure object-oriented programming language. Okay. This is about pure object-oriented. Now you know Java is the platform independent programming language. It's on any operating system or any microprocessor, we can run the Java application. This Java is the machine independent programming language. On many machines like smartphones, set-top boxes, routers, printers, on many machines you can run the Java application. Okay, so it is machine independent and it is a pure object-oriented programming language because we define each and every member inside of the class. Next feature is, I'm calling this Java as the compiled and interpreted programming language. So this Java is the compiled and interpreted programming language. Listen carefully here. First two versions, initially Java was interpreted programming language. Initially Java was interpreted programming language. Okay. First two versions of Java was the interpreted programming language. So to improve the performance of Java application in Java 3 version, means in JDK 1.3 version, JIT compiler was added. Okay, so initially Java was interpreted programming language, but later they made this as they added compiler also. Then Java became both compiled and interpreted programming language. So first two versions, Java 1.0, 1.1, 1.2. There's three versions. Okay, Java was the interpreted programming language only. But in the 1.3 version, they added JIT compiler. So now JVM has compiler and interpreter both. JIT stands for just in time. JIT stands for just in time. So this JIT compiler was added to the JVM in the Java 3 version. See, you already know the execution process of a Java program. Who is responsible to run the Java application? JVM. So JVM has execution engine. JVM has execution engine to run the Java application. JVM has execution engine. This JVM has initially only interpreter was there. Interpreter. So interpreter translates line by line. It takes a lot of time when it is processing the loops or recursions. It takes a lot of time. Okay, so that's why to improve the performance of the Java application, in the Java 3 version, they added JIT compiler. Now JVM execution engine has interpreter and JIT compiler, both are there. Okay, who is responsible to run the Java application? JVM. JVM stands for Java Virtual Machine. This is a special software used to run the Java application. So that JVM has execution engine that executes our Java application. So that execution engine has both interpreter and JIT compiler. Initially only interpreter was there. Later they added JIT compiler to the execution engine to improve the performance of the application. Now in latest versions of Java JVM execution engine has both interpreter and JIT compiler. Okay, so some code will be translated by the interpreter, some code will be translated by the JIT compiler. Okay, so code will be distributed between this compiler and interpreter. Some code will be translated by interpreter, some code will be translated by the compiler. If single statements are there, interpreter performance will be more. In case of recursion, in case of loops, okay, JIT compiler performance will be more. So for some code, JIT compiler performance will be more. For some statements, interpreter performance will be more. So that's why the code will be distributed among the interpreter and JIT compiler. They translate that byte code to the machine code. Initially only interpreter was there. In the Java 3 version, JIT compiler added. Now JVM execution engine has both compiler and interpreter. So you can say Java is the compiled and interpreted programming language. Okay, this is compiled and interpreted. Next feature. Next feature is robust. Listen. I'm calling this Java is the robust programming language. So the general meaning of robust is robust means strong. I'm calling Java is the strong programming language because of two reasons. So this Java is the strong programming language because of two reasons. First feature is because of this exception handling features and because of automatic memory management. Just a minute, sorry. See here. So just a minute. So I'm calling Java is the robust programming language. Robust means strong. So we are calling this Java as the strong programming language because of two reasons. First reason is because of its exception handling features. And second reason is because of its automatic memory management. So first say about exception handling features. What is this exception handling concept? So exception handling. See, there are two types of errors. There are two types of errors. The errors, two types are there. What are those? First one is compile time errors. Second one is runtime errors. So there are two types of errors. First one is compile time errors. Second one is runtime errors. Two types of errors are there. These compile time errors are occur at compile time. These compile time errors occur at compile time due to the syntax mistakes. Correct compile time. So compile time errors occur due to the syntax mistakes. For example, in the program, whenever we are typing the program, if any double quote missed, we start a double quote, we forgot to terminate the double quote. The double quote I'm writing some string. So this double quote must be terminated. The statement ending we must write semicolon. Okay, if opening parenthesis is there, we must close the parenthesis. So if any parenthesis is missing, or semicolon is missing, or double quote is missing, inside these are called syntax mistakes. So when we compile the program, Java compiler checks such type of syntax mistakes. And if any syntax mistakes are there, it raises the compile time errors. So the errors occur at compile time. Means when we are compiling the program, after writing the program, we are compiling the program. So when we compile the program, at that time, if any syntax mistakes are there in our program, compile time errors will be generated. So these compile time errors are not that much dangerous because compiler is checking and showing to us, we can correct them by reading that message. But whereas these runtime errors are very, very dangerous. Runtime errors occur at runtime. means at the time of program execution. At the time of program execution means when it is running the program. At the time of program execution, these errors will be checked. These errors will be checked. So when the program is executing, at that time, if any errors are occurring, those are called runtime errors. So when we are running the program, at that time, if any errors are occurring, we are calling them as runtime errors. So they occur at runtime. Okay, at the time of program execution, these errors may be generated. So due to several reasons, these runtime errors may occur. Like when we try to divide with 0, runtime error may occur. When array index is out of range, this runtime error may occur. For example, see here, I'm writing one simple program. What is the problem with this runtime error? Listen carefully. I'm writing one program here, Java program. So here we are writing a Java program like this. Total 100 lines code is there. Total 100 lines code is there. This is 100 lines program. At some line, x value is there, that is 10. Y value is there, that is 0. At some line, I'm trying to print x by y value. System.out.println x by y. So here in this statement, runtime error will occur. Okay, maybe assume that this is 50th line. This is 50th line. At 50th line, I'm trying to divide with 0. This is remaining code. Total 100 lines code is there. At 50th line, I'm trying to divide with 0. X value 10 now, y value 0. I'm trying to divide with 0. Now here at this 50th line, runtime error will occur. When runtime error occurs, our application will be closed in the middle of execution. It will not execute this remaining 50 lines code. So this remaining 50 lines code will not be executed and our application will be closed in the middle of execution. This is the problem with runtime error. So when runtime error occurs, our application will be closed in the middle of execution. When we are trying to divide with 0, observe carefully here. X value is 10, y value is 0. System.out.println x by y. We are writing like this. So here syntactically it is perfect. So compiler will not check. But at runtime, if you give y value as 2, no problem. 10 by 2, computer can calculate it. It gives prints result as 5. But I'm giving y value as 0. So we are trying to divide with 0 at 50th line. Now computer cannot calculate it. Runtime error will be generated. So when runtime error occurs, it will not execute this remaining code now. So this remaining 50 lines code will not be get executed. Our application will be closed in the middle of execution. So it is not executing remaining code and it is closing the application abnormally. These are the problems with runtime errors. So that's why as a programmer, we must handle such type of runtime errors. Okay, for example, here one array is there. Array size is 10. But in the program, we are writing this statement. Array size is 10 now. At x of 50th location, I'm trying to store 100 value. What is the array size? 10. Array size is 10. One array declared like this. Int x array equals to new int of 10. What is the array size now? 10. Array indexing starts from 0, means minimum index value 0, maximum index value 9. So only 0 to 9 memory locations are available. I'm trying to store 100 value at 50th location, at 50th index location. 50th index position is not available. How can you store the value? But syntactically it is perfect. x of 50 equals 100. At x of 50th index position, store 100 value. We are instructing this one. Syntactically, it is perfect. So compiler will not check it. But at runtime, when the program is executing, now JVM searches for x of 50 location. But x of 50 location is not available. Till x of 9 only available. So now runtime error will be raised. So when runtime error raised at this statement, it will not execute remaining code. Our application will be closed in the middle of execution. So this is the problem with the runtime error. Okay. So to handle this type of runtime errors, this Java is providing many exception classes. So handling this runtime errors is called exception handling. Exception handling means the mechanism of handling runtime errors. The mechanism of handling runtime errors is called exception handling. So for exception handling, Java provides several classes to handle runtime exceptions. So to handle runtime exceptions, Java provides several classes to us, and we can also define our own exception classes. These are called user-defined exceptions. We can define our own exception classes also to handle runtime exception. Okay. So because of this reason, you can say this Java is the robust programming language. It has both compiler checking and runtime checking also. So the mechanism of handling runtime errors is called exception handling. Okay, and because of its automatic memory management also, JVM is responsible to run the Java application. So JVM has class loader. This class loader is responsible to allocate the memory. So JVM takes care about the memory allocation and memory deallocation. So in case of C++, once memory is allocated at runtime, we must destroy that memory. That is a programmer's responsibility. But whereas in Java, garbage collector is there. This garbage collector removes unwanted objects, unreferenced objects, unwanted objects automatically. So we are not responsible for the memory destroy. Okay. Whereas in C++, we allocated memory means we must destroy the memory. Otherwise, that memory will not be destroyed. To allocate the memory, we use new operator in C++. To destroy the memory, we use delete operator in C++. So if you allocate the memory using new means, you must use delete. But whereas in case of Java, we are not responsible to remove the objects to destroy the memory. Garbage collector, JVM has garbage collector. It takes care about destroying the objects. And the class loader is responsible to allocate the memory. So JVM is taking care of memory allocation and memory deallocation. So because of this automatic memory management, so garbage collector removes unwanted objects because of this automatic memory management. And because of this exception handling features, you can say Java is the robust programming language. We're calling this as a strong programming language because automatic memory management is there. So unwanted objects will be removed automatically by the garbage collector, and it can handle many runtime errors. The mechanism of handling runtime errors is called exception handling. So whereas these features are not available in the C++. So that's why we are calling this Java is the robust. This is a robust programming language, strong programming language. Now I'm stopping the session here. In today's session, what we discussed, just in the features, we discussed about machine independency, pure object oriented, compiled and interpreted, and robust. These 4 features we discussed. Okay. Platform independency means the application developed in Java can run on many platforms, means many operating systems and many microprocessors. Mission independency means the software developed in Java can run on many machines like set-top boxes, routers, ATM machines, etc. This Java is the pure object-oriented programming language because we define each and every member inside of the class, including main also. And this Java is the compiled and interpreted programming language. JVM execution engine has interpreter and JIT compiler. Initially, only interpreter was there. In the Java 1.3 version, they added JIT compiler to the JVM execution engine. To improve the performance, they added the JIT compiler. JIT stands for just in time. So that's why we are calling Java as the compiled and interpreted programming language. This is a robust programming language, means it is a strong programming language because automatic memory management is available. JVM takes care of memory allocation and memory deallocation. And it is providing many exception handling features to us. So that's why we are calling Java as the robust programming language. In the next session, I explain the remaining features. Now I'm stopping the session here.